In a previous lesson, you learned how to extend sine, cosine, and tangent beyond acute angles so that we could find trig values for larger angles, obtuse angles like 100 or even 200 degrees. What you're going to learn in this video is how to find trig values for angles that are negative, less than 0, or beyond 360 degrees. You should also understand that those same angle measures will often be written as radian measures, and unlike degrees, where we put the little circle to indicate that it's degrees, radians don't carry their own symbol. So if there is no degree symbol, you can assume that it is radians. Alright, so let's start by considering that we already know how to find positive angles. So let's look at an angle that you should already be familiar with. If you think about 60 degrees, that's about right here. So we're thinking about this angle I'm drawing in red, and hopefully you know from class that the coordinates of the unit circle for 60 degrees, that ray would intersect the unit circle at 1/2, square root of 3 over 2. And so that allows us to find the cosine of 60 degrees is the x-coordinate, 1/2. The sine of 60 degrees is the y-coordinate, or root 3 over 2. And I'm going to write it up here. The tangent of 60 degrees is y over x. And if you do root 3 over 2 over 1/2, the 2's cancel out and you just get root 3. Okay, now I'm going to use green and I'm going to show you what to do if you have negative 60 degrees. Well, we always start our angles right here in standard position. Negative 60 means you're going to go the same rotation but in the clockwise direction. And because everything is symmetric, the coordinates down here, well, the x-coordinate is going to be the same, 1/2. But the y-coordinate is going to be negative root 3 over 2. So that allows us, let me label this negative 60 degrees, that allows us to determine the cosine of negative 60 degrees. Well, the x-coordinate is 1/2. And then the sine of negative 60 degrees, the y-coordinate is negative root 3 over 2. And finally, the tangent of negative 60 degrees. If you do y over x, you're going to get negative square root of 3. So that's how you do negative degree measures. I'm going to erase all that in a moment so that I can show you a similar problem with a radian measure. So be sure to get that into your notes, pause the video if you need to, and let's get that out of here. And now we're going to look at a negative radian measure. So let's consider negative 4 pi over 3. Negative 4 pi over 3. Well, it'll be very useful to look at the unit circle handout that you have. 4 pi over 3 is right here. 4 pi over 3. Which means starting here, you got to rotate all the way around to there. So I want you to think about doing that in the opposite direction. If we want to do negative 4 pi over 3, we're going to start here. And we're going to go the same distance, 1, 2, and we're going to go all the way up to here. So right here is negative 4 pi over 3. And then again, it's useful to look at your unit circle handout. The cosine of negative 4 pi over 3, well, that's right here, and the coordinates of that point are negative 1/2, square root of 3 over 2. So the cosine is negative 1/2. The sine of negative 4 pi over 3, well, that's your y-coordinate, which is root 3 over 2. And the tangent of negative 4 pi over 3, if you do y over x and then simplify, you're going to get negative square root of 3. So there you have it. That's how you find trig values for angles that are negative. Now we're going to look at what to do if your angle measure is actually more than 360, more than 2 pi, or similarly less than negative 360 or negative 2 pi. So the secret to figuring these out is to find what's called a coterminal angle, and a coterminal angle is one that ends in the same place. So first we're going to consider, let's do 510 degrees. Well, we want to find a coterminal angle, so let's think about this. If you go all the way around the circle, that's 360 degrees. But we've gone more than that. How much more? Well, let's subtract 360 from 510. Guess I already have my minus. 11 minus 6 is 5. 4 minus 3 is 1. So 510 is one full revolution plus another 150 degrees. So we would say that 510 and 150 degrees are what we call coterminal. And what that means is they'll have the same trig values. So 150 degrees is right here. So in order to find the sine, cosine, and tangent of 510 degrees, we just use the coordinates of 150 degrees, which are negative root 3 over 2, comma 1/2. So that tells you then that the cosine of 510 degrees would be the x-coordinate, negative root 3 over 2. And you're going to do something similar for sine and tangent. You're going to use the y value for sine, and you're going to do y over x for tangent. Pause the video if you need to, because I'm about to erase that and do another example. Alright, so the next example, we're going to look at an angle that is even more than 2 revolutions. So the angle we're going to look at next is 750 degrees. So again, that's more than 360, so I'm going to figure out how much more by subtracting, and it's still more than 360, so I'm going to subtract 360 again. 9 minus 6 is 3. So essentially for this one, you're going to consider the coordinates for 30 degrees, root 3 over 2, comma 1/2. So you'll use those x and y values to find the sine, cosine, and tangent of 750 degrees. If you had thought about it, you might have realized that 360 doubled is 720, so you could have subtracted off 2 revolutions in one step. Again, I'm going to erase that to do another example, so pause the video if you need to copy that down. Okay, our final example before I give you your homework assignment will be a negative radian measure. So suppose you had negative 29 pi over 6. Well, what I'm going to do in this case is add 2 pi, because that's an entire revolution, and that will give me a coterminal angle. Wherever negative 29 pi over 6 is, if I add 2 pi, that'll take me all the way around the circle, and I'll be back in the same place. Notice that in order to do this addition, you're going to need to think of 2 pi as 12 pi over 6. And I can already see that that isn't going to be enough. It's still going to be something that I don't know, so I'm going to add another 12 pi over 6. And you're going to get negative, because this is 24 pi over 6, which is essentially 2 complete revolutions, and I would get negative 5 pi over 6. Now from here, if you want to add another 12 pi over 6, you would then be at 7 pi over 6, and if you check your unit circle, 7 pi over 6 is right about here. You could have also worked with the negative 5 pi over 6. Since 5 pi over 6 is here, negative 5 pi over 6 would be here. You can do it either way, but what you need to know then are the x and y values of this coterminal location, which are negative root 3 over 2 and negative 1/2. So the, again, I need to clear some room here, so let's get rid of that. And now that I have the coterminal location, I know that the cosine of negative 29 pi over 6 is the x-coordinate, negative root 3 over 2. And the sine of negative 29 pi over 6 would be negative 1/2. And the tangent of negative 29 pi over 6, if I do negative 1/2 over negative root 3 over 2, the negatives cancel. I get 1 over root 3. I'd rather you rationalize the denominator and write it as root 3 over 3. All right, that's how you do it. Your homework assignment, you're going to find it very useful to have your unit circle handout so that you can find the sine, cosine, and tangent of each angle measure. Remember, numbers 1 and 2 are degrees, so for numbers 1 and 2, you're going to add or subtract multiples of 360 degrees to get a location that's already on your unit circle. For these two, 8 pi over 3, negative 29 pi over 6, you're going to have to add or subtract multiples of 2 pi. These are in radians. And once you find a coterminal angle that's already on your unit circle handout, you'll be able to use the xy coordinates to find sine, cosine, and tangent. Good luck. Have that ready for class next time.